Good afternoon, everyone. Myself, Karan Choudhary. I am Deputy Director at Mahananobis National Crop Forecast Center. So, I'll be giving a presentation about the. So, I'll be talking about the various data sources where you can access the different data sets such as weather, rainfall, temperature, or various remote sensing freely accessible data for sentinels or Landsat, and also some low resolution data such as MoDIS and VIS. And also we talk about some of the ground truth data which MNCFC is having. Now it's fine. So I'll be talking about the data sources where you can access the like freely accessible temperature, rainfall data like through IMD or through freely accessible satellite data from European satellite like Sentinels, Landsat, NASA-based satellites like VIRS and MODIS, and also basic some of the free platforms such as Google Earth Engine or some kind of libraries which you can use for accessing and processing those data sets. So first of all, I just want to give you a brief overview. What are the data sets are available? What kind of parameter you can generate, and what are the possible applications can be achieved through the using those data sets. So as you can see on the left side, the data is basically first of all is the weather related data, which is very important in the agriculture domain, like rainfall, temperature, humidity, and various parameters. And remote sensing, you can see several platforms are there like Sentinel-1 for SAR, Sentinel-2 is the optical satellite, then Landsat 8, 9, it's a legacy data set. Even you can have a Landsat 1, 2, 3, 4, 5 from 1970 onwards, you can have access through Google Earth Engine, and various tools are available. And also like for specifically for soil moisture, SMAP is there, coarse resolution data set. And some of the optical satellite of around 500 meter or 250 meter VIRS and MODIS. Then also, of course, we have some field data also at MNCFC, like crop photographs, location and condition, and some crop cutting experiment data also, and also some of the hydrological data which is freely accessible like reservoir storages and groundwater information. And these are the some of the parameters like from remote sensing you can generate like NDVI, which is a chlorophyll based index, like it talks about the crop health. LSWI is the canopy surface moisture either of the soil or either of the crop. Then SAR backscatter is also a very good indicator of the crop health also, and depends on several other performance of the crop. And FFR, LAI is the leaf area index, LST is the land surface temperature, soil moisture, even fire events also is can be monitored using thermal data. And these days, like now in Punjab, Haryana, stubble burning, you can monitor. Then also land use land cover can be generated using satellite data sets. And these are some of the applications like crop sowing patterns you can get from the satellite if you have time series remote sensing data. You can also classify and assess the acreage at certain level like block level or district level. You can monitor the crop health condition. What is the condition at the particular point of time based on the several NDVI, LSWI indicators. Then also, and these remote sensing and weather data sets can be input for the yield estimation. Also, crop harvesting can be monitored every 5 days as Sentinel-1 data is available every 5 days. It's a very high frequency for monitoring these kind of harvesting and crop health. And drought monitoring as National Drought Manual says about the various indicators such as rainfall, and even remote sensing is one of the parameter in the drought manual for monitoring drought and declaration. And of course, for crop insurance solution, NDVI and these parameter remote sensing drive parameters are very important and can play a vital role for crop insurance solution. And also, of course, I talked about the stubble burning and burnt area. So first of all, we'll see some of the data sources of the weather. Like first and foremost, like Indian Meteorological Department data. So IMD provide rainfall grid data at 0.25 degree, which is around 25 kilometer spatial resolution. It is available on daily scale, and it is available from the 1950, I think. So you can go on the website. I have given the link also there. And second, minimum and maximum temperature is available at both 1 degree and means around 100 kilometer, 110 kilometer, and also at 50 kilometer spatial resolution daily data, and of course for the long-term data also. And also IMD also published district level rainfall statistics based on daily, weekly, and seasonal reports in the PDF files kind of thing. So you can download those and you can make convert it into a GIS format. I'll just go to this link and I'll show you from where you can get this kind of data sets. So you can get the grid data from IMD Pune website. So here you can, I think internet is. The internet is, I think, a little bit slow, on the slower side. Yeah, it open now. So here, using this link, you can get to these links. So you can see weekly temperature, weekly rainfall, daily temperature. So here, if you go to the graded data archive, so you can see rainfall binary and .NetCDF format. So archive means long-term data is there. So if you click here, you will get the yearly file. So you'll have a, you can select the year here from 1901 to 2022. You have a yearly file. So in a single file, you have a 365 days rainfall data. So you can download this long-term data, and you can, a lot of tools, a lot of Python libraries are also available, like IMD and IMD daily. So using that, you can convert it into a suitable format like geotiff and also pandas and NumPy. A lot of libraries are available. Really, you can access this data and you can convert into usable format. And if you want to access the daily, this is the real-time data. So every day, on the daily basis, you will get the daily, every day single file for every day. You can, and you can, for 2022, you can download the yearly, and for the current season, you can keep on downloading daily, or even the API is also available. Someone has developed the IMD daily API. So using that also, you can create a pipeline automatic download. So in Drought portal, we are doing that. We have developed a Drought portal, in that we have built a pipeline. So automatically every day it will trigger at 10 a.m. It will check for data, and it will fetch the data, and it will create a statistics at district and sub-district level. I'll show you that also in the at the end of my presentation. So here you can just give the date, and you can download the data sets. So on the daily basis, you can download this. Similarly, for temperature also, these data sets are available, like weekly temperature is there. So this is the maximum and minimum temperature at 1 degree archive data. And similarly for daily, we have daily maximum temperature, daily minimum temperature. So you can download the temperature data also, but the spatial resolution is bit coarser than the rainfall data. So yeah, these are the data sets for, and then another district level statistics are also available at IMD website. So if you go on this this link, so you'll get the monthly, like it is showing the monthly statistics cumulative from whole season, and weekly and daily. So they publish the data sets in the PDF form also. Like if you go for rainfall statistics here, so you'll get these kind of statistics, and there is a lot of options are there. District week by week departures. So you can have a, for district wise, what are the departures, weekly departures of the rainfall. Even you can see the rainfall distribution. So a lot of statistics are there, but these you have to convert into the GIS using your shapefiles. You have to join the fields and all. You have to match the names. So also automatic pipeline can also be developed using the like Python, and a lot of tools are available these days. So these are the two sources. So, but block level data is not available. So MD, because there are not sufficient number of stations. But some states like Karnataka, Andhra Pradesh, Maharashtra, they publish the data on their website. So you can go on those websites and download the taluk level or mandal level data, very high resolution rainfall data. But those are very state specific. But uniformly, you can use the grid data for at national scale kind of analysis. And of course, some other data sets are there, like CPC, NASA Power 1 degree, CPC is 10 km chips, GS map. And some of the data sets like the GS map, you can simply, these are available in Google Earth Engine also. So you, like chips and GS map, both are accessible in the Google Earth. You can use Google Earth Engine for accessing. So on the simple 3-4 lines of code, you can just give the start date and end date. You can access the chips and this GS map data, and you can visualize, you can do the anomaly analysis. You can see that, you can aggregate the statistics and all. So like this is the GS map rainfall aggregated for the period of, I think, 1st June to 31st August. So these are the tools are available on a single click. You will be able to access around 3 months of data sets. And similarly, you can access this data for the past, I think 1981, this data is available. Chips data, sorry, this one is available for 2000, and chips data is available for 1981. So you can even do the looping, and you can access the data of previous around 20 years. So like this, you can visualize the data. If you click here, you will get the information of the data here also. What are the precipitation aggregated over the 3 months, like 834 millimeter. And you can do the coloring, and also no need to download the data directly. It is available in the Google Earth Engine, and you can just access it. And like when I talked about this gridded data set, so we have derived the dry spell events also from that. So if you have the access to the data, you can do these kind of analysis. You can see how many dry spells have occurred this season: 28 days, 21 days, 14. So you can see the basically pattern of the dry spell and which are the cropped areas where more dry spells are there. Like you can see in the analysis, the paddy area is having very less number of dry spells compared to the other grown areas. So these kind of analysis can be done using these rainfall data. Very at national scale, you can see the picture of the rainfall distribution. And this analysis we have done using the district level data. That was from the gridded level. So you can see how many number of weeks there are deficient rainfall this current season. As you can see, this season was the special distribution as well as the temporal distribution was very skewed. So you can see most of the districts are having out of 17 weeks, 8 to 9 weeks, less than 50% deficient rainfall. So you can see how skewed the rainfall distribution was. And as per the drought manual, you can see these are the yellow districts which come under trigger one. So basically, the dry spell and this deficiency was pretty bad this season. And specifically, these are the areas like Eastern UP, Bihar, Karnataka, Rayalaseema, Maharashtra, Marathwada region, Gujarat, Rajasthan are major districts. So these kind of analytics you can build using the data sets, those rainfall data sets. And of course, the temperature, like in the Kharif season, temperature doesn't affect that much. Like paddy is the major crop, but during the Rabi season, of course, for the wheat crop and mustard crop, so for the frost and the high temperature, those grid data sets you can use for do the anomaly analysis. What are the hotspots area where the temperature anomaly is high or it is on the lower side for mustard crop? So these analysis you can do. What are the colder areas and warmer areas you can do? Now we'll move on to the remote sensing. Those were the weather data, some of the weather data sets. Of course, there are some more maybe available, but I have just tried to be very brief about that. So now next we talk about the remote sensing data sets. So a lot of free remote sensing data is available, and Sentinels you must be knowing, because Sentinel every 5 day Sentinel optical data and every 12 days Sentinel 1 SAR data is available. So a lot of research is being done using those data sets. So this is just a representation of what kind of satellites orbits are there, like polar and geosynchronous. So geosynchronous basically it stays on the one position. It is revolve around the Earth on the speed of the Earth only. So basically it will see the one part of the planet only. But here in polar orbit, it from north to south or south to north it will revolve. So after a few days, from 1 day or 2 day, 3 day or 5 day, depending on the revisit capability of satellite, it will visit the exact same region after a certain period of the time. So these are some of the data sets which are available. Like I talked about Sentinels, 10-meter data every 5 days, Sentinel and SAR, 12 every 12 day, 20-meter data. It should be 10-meter, and SWAT is 300 km. And we have Landsat legacy data from 1970, but recently 8 and 9 OLI sensor is there, 30-meter every 16 days there. And of course, we have some Indian satellite data like AV 56-meter, LIS 323, and LIS 4 is 6-meter. But those are right now, it's not publicly accessible, I think. But Landsat and Sentinels are publicly accessible across the platform. Numerous number of platforms are there, like in Earth Engine, in Sentinel Hub, Earth Explorer. A lot of platforms are there, and you can access those datasets very easily. And these are some of the coarse resolution satellite, like two are the major, like MODIS is the major one. From the 2000, we are getting this data. So we have a long-term data. You can do a lot of analysis, long-term analysis using this data. It is available at 3 special resolution, 250-meter, 500, and 1 kilometer. And several products have been launched by this NASA, and they're providing surface reflectance, even vegetation indices product directly. So no need to calculate the NDVIs. You can directly download those products, even LST, thermal anomalies for fire detection, and FFR, other biophysical parameter like FFR, LAI, and ET products. And continuing that legacy, VRA is the similar kind of platform, because MODIS is the already it's been 20 years. So VRA is a similar platform. It will continue this legacy. So the special resolution is 375 and 750-meter, and similar kind of products are available, like surface reflectance, VI. More or less the products are similar, and resolution is also similar. So, but the revisit of these satellites is every day. So during the Kharif season also, if you compose it in 15 days, you will get a cloud-free composite and you can do some kind of analysis. And of course, these days, some new harmonized products are also available. Like this one is their HLS dataset is available. So NASA has harmonized these two, Landsat and Sentinel. And every 2 to 3 days, they are providing 30-meter datasets. So they have merged the Sentinel and Landsat also. So every 2 to 3 days, you can have a datasets, harmonized and surface reflectance and brightness temperature data. So it's a virtual constellation of satellite, you can say. So these kind of harmonized datasets will enhance the temporal resolution of the datasets and get the more frequencies and more observations. So now I just want to show you the view of the snapshot of the satellite. Like this is the Sentinel image. Of course, you can, this is a area of Punjab, I think. So you can even see the field. But if you go to some Jharkhand or the eastern part, so you may not be able to see feel very distinguishedly. You cannot differentiate maybe due to the field sizes. And this is the SAR data. So SAR data is black and white. A single date is there. So you have to combine 2-3 dates to get a colorful product like this. So is this specific paddy area. So you can even differentiate the paddy transplantation dates also. So blue color is showing the early sown, then magenta is showing the normal sown, yellow one is the late transplanted. Means among these 3 dates, the yellow one is showing the last date transplanted. So basically, you can even get the transplantation date like approximate transplantation date of the paddy also. And all the urban, this white color you're seeing, these are urban areas because the backscatter is uniform and it is high. So that's why it is look like in a white color. And black colors, these are the black colors are showing the water body because the backscatter is continuously low in all 3 days. So these kind of products was very useful. This data is useful for rice mapping of the paddy crop and even also the transplantation date. And these are the example of the two low resolution dataset which I talked about, VIRS and MODI. So you can see in a single pass, you can see the whole country at once every day. But the resolution is 500 meter or 250 meter. So basically, you have to see the application of what is the application of this, because you cannot do a crop mapping using this resolution. So you can basically do a condition monitoring or those kind of stuff. But using these data sets, you can even go for a crop mapping also at field level. So both the data sets has pros and cons. So these are some of the parameters which you can derive using the satellite like NDVI. The first one is the basically chlorophyll based. So it will give you the basically health of a crop. So NDVI value, as the crop grows, NDVI value increases. If something happens due to some adverse weather condition or pest and something, so this value will get a dip. So you can basically monitor the health of crop. And second one is the LSWI. So it's a basically surface or canopy moisture index. So whatever there is on the surface, it will capture the moisture of that. If so, in the start of the season, you can even get the topmost soil moisture also condition kind of. And if the crop grows, so you will get the canopy moisture. Then radar backscatter is basically from the SAR data. How much, because radar is a SAR is a active sensor, so it will throw the pulse and it will get some backscatter. So this backscatter will be is a factor of many, like incidence angle, soil moisture, and kind of you can see the plant structure, rowing of the how the rows of the plant are there. So it depends on a lot of things. But yeah, in condition of drought, when the dryness is there, so obviously this backscatter get a drop. So you can even detect those kind of thing using this. And if very heavy rainfall happens and lodging of crop happens, so also this backscatter increases. You can capture those events also using this radar backscatter. Then other factors are FFR, LAI. These products are available from MODIS and VIRS. Even Sentinel is providing FFR. So you can use these parameters and it can go into the yield model for the analysis. And land surface temperature is also one of the parameter. It's different from the air temperature. So here's an example of the each of the parameter derived from the satellite. You can see from NDVI, LSWI, backscatter. So I have derived this using Earth Engine in a very easily. You can derive these indices using Earth Engine. Otherwise, you have to download the data set and it would take a lot of time to process those kind of data set. But in the Earth Engine, in a single click, you can get these kind of insights of at national scale. So these are some of the sources of remote sensing data, basically from where you can access and download. So a lot of, as I told you, that these satellite like Sentinel data is available from, I think, most of these platforms. In Earth Explorer also you can download from NASA Earth data, you can also download. So the accessibility is also very easy. You can download the data, you can process. And apart from this, you can access this data in the already like Google Earth Engine and Sentinel Hub. Some platforms are also there. So I will show you only one or two here. Like this is the link here. You can download the MODIS, VIRS, Aster, all the data sets using this link. You can have all the products which I talked about, FFR and everything in a single link. As you can see here, this ASTT is from Aster. So basically MOLA means MODIS Aqua, MOL is MODIS Terra. There are two different platforms are there. And VIRS is that. So if you click on MODIS, so all the products are there. So you can go on the NASA LPDAC website. You can see the definition of these products. So these number of products are available. So particularly for vegetation index, there is 13Q1 is there. So every 16 days data is available. So from 2002, you can access this data and you can download tiles for your Indian region. So recent one is 14 September. So till 28, I think September data is there. So you can download this tile, you can process if you want to do it offline. So this link is having VIRS, MODIS, and Nester data available at this. Only you have to just see these, what are these products, you have to see the definition and all. So no need to create account anywhere and this. So you can directly access the tiles here. So this is for low resolution data set. And for SMAP data, SMAP satellite based soil moisture, there is data is available in just this NASA Earth data portal. So even Sentinel, a lot of data sets are available, but SMAP data is very easily accessible if you type SMAP. So all the products related to the SMAP, all the level 4, if you want to see any level 4 product. So a lot of products of SMAP is available. So root zone soil moisture every 3 hour lead is available. You can download these data set from 2015 very easily. You just give the start date, end date, and just upload your shapefile here. And you can download the 3 hourly data sets. Even after downloading, you can convert these into GeoTIFF. It will give you the option of converting the projections and GeoTIFF and everything. So if I upload any shapefile here, so if you go to download, I think I have to log in. Yes. So here you can customize this even so you can convert the format and everything. Like here it will output format. So you can select the GeoTIFF and even other formats also. And you want to subset the data like I have uploaded the shapefile. So it will subset the data for Indian region only. Like this is the shapefile I have uploaded here. And projection also you can select like UTM or geographic. And also a lot of layers are available here. So you can select any one of them like either you download all the layers like soil moisture, root zone, like percentiles, root zone wetness. So whatever you can download, you can click those. And if you click here, so it will process this data set for you and you will get an email in, I think, 2 to 3 minutes and you can download the tiles. This is the example how you can download this kind of data set. So you can see these links for accessing the like Sentinel and Landsat also like Earth Explorer, Copernicus, Open Access Hub. You can access the Sentinel data here. Like some of the other derived data sets from these satellites, I is the one of the famous is this one ESA World Cover. So ESA has generated the global land cover product for 2020 and 2021 at 10-meter resolution using Sentinel-1 and Sentinel-2. So even you can download those uh, land use land cover data sets either using these link or either in Earth Engine also. You can access this dataset on single click. So these dataset have been ingested in Google Earth Engine also. So you can see the already data set image collection of this is available version 200. Version 200 means 2021 and version 100 means 2020. So both of the versions are available in Earth Engine. And I have just clipped it to my state, like Indian state. So you can access this and you can visualize. Even you can export this data from Earth Engine based on your area of interest. So like this, you can see this. So there is no need to download and or you can do the analysis here. Also, you can even extract the urban areas. It will give you the 9-fold classification, 9 classes. So you can visualize these. So these data sets are available, ingested already in the Earth Engine. And then second one is the dynamic world cover. So this also have been developed like extracted using the Sentinel one, but this is dynamic in nature. So for every Sentinel scene which is ingested in Earth Engine, automatically the land use land cover map for that particular scene is generated. So it is dynamic in nature. So using Sentinel-2 data, it has been generated. So this is Earth Engine app only. It's developed on the Earth Engine using machine learning and all. So for every scene of the Sentinel-2, you can have a land use land cover. So basically, instead of generating the land use land cover after 1 month, 3 months, every scene you will have this kind of product. So you can access these scenes in Earth Engine also. Then some of the reservoir storages monitored by the CWC, Central Water Commission. It's a government of India body. So they publish weekly report regarding the reservoirs. These are the major 150 reservoir in the country. So basically the 70% of the capacity they cover. So you can on the weekly basis, you can access this to bulletin and you can generate these kind of statistics. Okay, but this red one are the reservoir which are having the problem or severe deficit, because if you compare these with the current reservoir level with the past 10 years average, so you can see what are the reservoir are in the critical condition. So this is the link which I have shared here. So you can download the weekly. This is the report is in the PDF format, but you have to create the geospatial layer for that also. Like this, they provide weekly. And also NWIC has one portal, National Informatics Portal. National Water Informatics Portal is there, I think. So there also these information is available. Even groundwater data they are publishing online. So I think you can access the water related all the layers you can access, because if you have the command area of each of the reservoir, you can have a command area. So you can do some kind of analysis. Okay, what are the areas problematic due to these reservoirs? So those command boundaries, I think, reside with the Central Water Commission. So if you have access to that, you can do some kind of analysis using these data sets. And also some of the like ground truth data. This data is not in public domain like MNCFC. We collect this ground truth data for our analysis, like crop area mapping, condition, and a lot of other analysis we do collect ground truth data and basically CC data. So what we collect is location data, what are the condition, photographs, and this is the map on the top side. So we collect these kind of data every season, Rabi and Kharif. So each location will have certain attributes about the crop condition, like approximate time of sowing, what is the time of harvesting, expected time of harvesting, these kind of. And what we are trying to do using these data sets, we are trying to build some kind of library, because we have 4-5 year data, past year data. So like a lot of Sentinel satellite data is available. So using these data sets, we can generate some kind of spectral libraries. So if you have a like for major crop, wheat, paddy, or mustard, if you have a spectral library, so for the next season, you may not need that much of GT for classifying. Even using those spectral libraries, you can classify the data, and just for the validation purpose, you can use GT. So that's we are in the process of doing that. We are trying to generate spectral at least for 3-4 major crops. So that's about the data sets which I most. Yeah. No, that's right now it is not publicly available, but we are developing a platform. I think Murthy sir will tomorrow will talk about that platform also, Krishi DSS platform. So under that, we are developing a module for this, specifically for ground truth data and spectral library. So what we are trying to do, all those data sets, past year Sentinel, we try to generate those spectral and time series libraries. So any user can come and download and use those signatures for their classification or their analysis. So this we are proposed to do. Uh, that's the DSS is having lot of individual modules. I think in detail next tomorrow presentation maybe sir will talk about. So crop mapping is also one of the module. So idea is that, so if you have a model of a particular crop using this signature, so like these days, I think IBM and NASA have released some of the models for burnt area and from some crops. So they have used the Landsat data and created a model and made it public. So anybody can use that model, but that is for US continent only. So if you give 3-date image of Landsat, so idea is that only. So you have a GT, you have Sentinel data, you generate the library. So just if you give the fresh image of that period, particular period, so it should say, okay, it's a wheat crop or mustard crop. So idea is that. So that's about the data set. Now, some of the data analysis platform which is available like Google Earth Engine, I think you must be knowing about this is the freely accessible platform, but the computation power resources is limited for the free account. So it's a very good computing platform. Most of the data set which I talked about, Sentinel, MODIS, VIRS is readily available in the platform. You can simply call the data and you can run your geospatial analysis, whatever analysis, anomaly analysis, like 20 years data set of MODIS you can analyze in a matter of click. So this is the very powerful platform and all the historical imageries are available. This is the catalog. So like you see Sentinel, Harmonize and a lot of data sets are available in this. Then another one is GMaps. This GMap is a Python based library. This uses the GE basically data sets, but that is like Google Earth Engine is basically JavaScript based, though the visualization and everything is very powerful in JavaScript. But for Python, the documentation and the visualization is very limited. So that's why this someone has developed this GEMAP library. So visualization and geospatial analysis on the Google Earth Engine dataset using the Python. So this is also a very powerful library, and people are using these days these library. A lot of documentation is and videos are available for this library. And then of course the open source like QGIS is the desktop. This is the desktop base. This is not a cloud computing platform or anything. It's a simple desktop based analysis tool, but for map making and do some kind of quick analysis, you can use some alternate of the East React GIS. So, but here this is a GIS kind of a software. But if you want to do some kind of raster analysis and also very limited tools are available. But of course, a lot of plugins are available. And one of the plugin is the semi-automatic plugin. You can do the classification and all and download the data sets, remote sensing data set. So basically, you need to download a lot of plugins for doing if you want to do some kind of remote sensing analysis. The another one open source toolbox is there. Desktop base is Orfeo. So image segment, very good image segmentation open source algorithm is available, because otherwise you need to use Trimble recognition. It's a proprietary software, but here you can do the segmentation using this toolbox, and a lot of plugins for QGIS also is available for this. And here is the snapshot of I try to do some kind of segmentation using this tool only. So even machine learning classification is also available in this tool. And of course, Snap Toolbox is there for only for Sentinel. So Sentinel ESA has developed this for processing of their Sentinel-1, Sentinel-2, or Sentinel-3 datasets. So you can do the pre-processing of the dataset, even classification, everything using this. And if you don't want to use these, so a lot of open source Python-based libraries these days are available for handling raster data like GDAL and OGR for handling the raster vector data set, and then raster IO is there. GeoPandas for shape files and means vector data set. For machine learning, there is skitlearn is there. And for accessing Sentinel data through APIs, you can use Sentinel set, GMap, of course. I already explained in PyPro. So a lot of even Python-based library are there. So you can generate your own pipeline for pre-processing, downloading, classification. So if you're interested in development or also a lot of people are using these libraries for developing their own full pipeline of the process. So another one I will talk about this data set. So Ministry of Agriculture has developed a drought portal, and it is right now it is online. So we try to basically bring all the data set related to the drought on single platform. So like rainfall, soil moisture, crop condition based on satellite. So idea is to bring all the data set which are mentioned in the National Drought Manual, like rainfall, reservoir storage, soil moisture, dry spells, and provide this data set on single platform to the state. So this is the snapshot. I'll just run through this and I'll just show you what are the data sets are available here. So this is the dashboard. So here a lot of this drop down will show you the different parameters Like you can see the first one is the rainfall. So you have a cumulative rainfall also from 1st June to 30 September 110. Every date, if you click on the this, you can see the how the temporally rainfall is behaving compared to the normal. So this is developed using the IMD grid data only, 0.25 grid data. So you can see the weekly also if you want to see the weekly rainfall. So you can see how okay, what is the week by week rainfall deficiency is there. So all the weeks you can see. And if you click here, so you can see the weekly compared to the normal, what is the distribution. So you can see the cumulative amount also and what is the distribution of the rainfall. These kind of things you can see. And also you can see the tree as in drought when something called trigger one is there based on the rainfall and dry spells. So you can see what are the possible districts which are having problem means rainfall deficiency due to drought, due to dry spell as well as rainfall deficiency. So these red ones are showing okay, these are the districts either having the rainfall deficiency very high or either having 3 weeks of dry spell. So very quickly you can see okay which side of the country is having a rainfall deficiency or dry spell. Then we are uploading the crop zone area. Of course, this crop zone area is taken from the Ministry of Science, it's a very coarse state level data. Then you can see the LSWI derived from the Moody's dataset, NDVI, LSWI deviations. So you can, at the national scale, you can see what are the districts are having crop condition problem. Then moisture based also that root zones, soil moisture from the SMAP. We are we are downloading and we are generating the statistics and uploading here. So you can see the root zone soil moisture condition, moisture adequacy index, water balance using water balance methodology, and those reservoir 150 which we talked about. So those reservoir weekly we are updating, we are generating the reservoir storage index and we are uploading here. So if you click on the reservoir, you can see the behavior of the reservoir compared to the last year normal. So what are the current situation of the reservoir storages? So these kind of some kind of analytics we are trying to build. So all the parameters related to the drought, we're trying to bring at one platform. Like even SPI also 1 month SPI we are generating using the same IMD dataset. So month by month you can see monthly SPI, which is better, where is the which areas are drier. And of course, some of the other DSS tools are there, but that is entirely for the state kind of thing because this follows the protocol of drought manual. So this is just I want to show you that these are the drought late data set is available on the uh, internet. So yeah, just someone asks about the publicly available model, some kind of. So as you must be knowing about that, the Meta AI has made public one SAM segment anything model. So basically, you show the RGB image, 3-band image, so it will give you the objects from that. Then someone has basically modified and made it SAM geospatial for geospatial or remote sensing imagery. But yeah, only for 3 bands RGB. So using the tiles which are available in WMS tiles available for Google or Bing, so you can use that and you can generate the segments like in bottom. You can see this. This is the Google imagery. This is the segmented objects, and then the vector data extracted from that. So I did this before that SAM Geo was there, but someone has already generated SAM Geo. So you can use this, you can give the imagery, WMS styles of that, and it will give you the shapefile or GeoJSON. So these kind of models are these days are made public by the different agencies. So this is very helpful. If you have a particular farm boundaries, so then you can monitor you can monitor the crops or condition at particular parcel level instead of pixel level because see, like high resolution imageries are not freely accessible. So these models which people have used only if you know about the WMS tiles kind of thing, simple, it's a RGB tile, it's not the actual data from the base image. So the resolution of Google and this are more than better than 1 meter. So those tiles people are using only simple RGB. So that is not actual data. This is RGB, basically WMS tiles only. So it's better than 1 meter they are using because this kind of segmentation in India the field size is very small, so it has to be 50 centimeter or as you can see here, this is around 30 centimeter or maybe better than imagery. So these kind of images are needed for doing the extracting the field boundaries. means Sentinel, people are doing using Sentinel 2 also, but for that European countries and the Western countries they are doing, because the field sizes are very large. But a country like India, it has to be better than 1 meter or 50 centimeter. Not ISRO. We are actually we are doing some pilot studies on this. Tomorrow, Murthy sir maybe talk about this also. We are working on this parcel level segmentation also. This is a snapshot of that study. This is of some Indian data set. So we are partnered with the industry and we have working with that. So we have some data sets for this. Certain for certain districts, we have this segment. We are evaluating that. What is the accuracy of that? What are the basically whether it's under segmented are there, over segmentation is there. So the quality we are currently. So on the top, you're seeing that the base is the drone imagery, and this yellow one is the boundaries generated from the high resolution satellite data, around 30 centimeters. So you can see the quality is quite good. So it is sitting on the drone imagery pretty good, and all the segments are able to. So, but in certain parts, accuracy is good, but certain parts there is over segmentation, under segmentation is there. Yeah. No, no, no. Yeah, we have a segmented boundary generated from some high resolution imagery. So now we want to evaluate that whether those boundaries are okay or not. So how you will evaluate? Either you go on the field, segment by segment, you see whether each parcel is segmented properly or not. If you have a recent imagery of drone and all, so you can visually see the parcels, then you can evaluate. So those we are trying to do.
SAS Planet image,
Which
SS Planet image, Google.
segmentation can be done on any image. This is just an algorithm. Some deep learning models are there. It can be done, but means you need very high resolution for that, because but the one parcel should be big enough to you will be able to resolve that using the resolution of that image. So suppose if you do segmentation, yeah, if you run model on 10-meter image, so maybe you will get a good result in Punjab, maybe because the field sizes are big. But if you run on Jharkhand or some West Bengal, those kind of areas, maybe you'll not be able to resolve the parcel. So it can be run on any image. But thing is this, it depends on the resolution. You need a very good resolution.
So when we get
Mike se boliye.
hello, sir, when we do this segmentation in Sentinel-2, then we got multiple polygon geometry. So how to deal with it?
Yeah, basically those are the processing problems.
Yeah.
You will get multiple those edges very. You can see the edges very smooth, but those post processing algorithms also you have to apply. You have to make the edges smooth and all. So these are the otherwise you'll get a very shady kind of segmentation in the at first instance.
Because road and tea plantation are included in this.
Hmm?
Roads and tea plantation are included in this.
So basically, our main idea is to see what features you want to take it as a background that you have to decide. Like in our case, we are seeing urban areas and all the like roads and all. We are seeing it as a background. So we are only basically it's a model. Whatever you will train with, we are training it with the orchard, field boundaries, trees. So it will basically and other things we are putting it as a background. So it will basically give the output according to that also. If you train that model using those things, like if you want to extract the buildings and everything, so it's all depend on the training.
Thank you.
So we are treating that as a background, urban areas and everything. Because as far as agriculture is concerned, we need to know about the parcel boundaries or trees also, because trees is also very important to see the tree cover for agroforestry application. So trees are also very important. So how many trees are there on the field bunds? So those are also very important. I was going through the net, actually found some of the model like IBM, NASA has some of the geospatial model. These three they have made public for Landsat and Sentinel HLS harmonized dataset. So if you give the dataset to three datasets of these kind of three temporal images, so it will give you the output like this. Classification of certain crops are there, but these model are for the like US continent, like burn scar detection. You give the image, 3-band image, so it will give you these kind of output. So these models they have made public. So you can give input to that image. You can see, okay, some burnt area you can extract. So, but those model are trained on those US continent side, and even you can extract the water bodies. So these kind of models are people are making public, so you can use that. Even someone can make these kind of model for Indian continent also, our country also. Like if someone has a lot of ground truth data or for certain crop or something, so even you can train a model and you can make it public, so other people can also use those models. So these are the all about the data sets which I try to summarize. Okay, these are the data sets available in the public domain. Some of the application using these data sets, of course, you can do the crop mapping of certain crops. Like you can see using Sentinel data 1 and 2. You have a ground truth data, you can generate those profiles and you can generate the output. Then this is the recent image of, I tried to capture the harvesting status of in Punjab, Amritsar already harvesting started. So we try to capture how much percentage area has been harvested. Wheat, you can monitor the, because every 5 days this image is available. You can see, okay, how much areas are harvested every 5 days. The transplantation of the Kharif, because you can see Punjab, Haryana in July transplantation happens, but West Bengal and Bihar, you see in till August and this transplanting happens. So these kind of patterns you can also analyze. Okay, what are the late sowing areas, early sowing areas, and how much area the company. As you can see here, you can see the uh, wheat basically profile. So in Ujjain, you can see the earliest Ujjain sowing has been done and the latest in the Bihar. But you see the harvesting window is very small, but the sowing window is very high. So you can see these kind of pattern and you can generate these kind of maps, late sown, early sown, and because you can analyze the how much impact high temperature gonna take on each category. Because late sown will be having much more impact of high temperature. So these kind of analysis can be done. Like flood mapping, you can using before after images. If you are having for SAR data, you can extract these. And even you can generate in Earth Engine, you can generate these kind of app. So if you are doing some analysis in Earth Engine, you can create an application for that. So you can share the URL to anybody and they can simply access that. You can see, suppose you have generated some map, you just generate the URL and share to your friend or anybody. So that person will be able to see the your analysis without any login or everything. And login or like this, you can. So this is the power of the Earth Engine basically. So even application can be developed in the Earth Engine instead of analysis. So as you can see here, this is the before image, before the event image of the SAR. This is the normal water bodies. And if you open the after image, after the event image, you will see a lot of black. So backscatter is certainly get a dip due to the heavy rainfall. And you can extract the flood inundation area or you water inundated areas due to the rainfall. You can, a simple logic is there, the rate of change of the backscatter you can apply. So this analysis can be accessed by anybody. Instead of the map, you can even zoom in, zoom out, and you can open the satellite image in the background of the Google. You can see what are the agriculture areas. So these kind of tools are available these days, which you can use. Then this is the like crop condition analysis. Like this season, we done what are the areas under stress. This is also done in the engine, accessing the 10 years data, and you can compare. Okay, what is the crop condition? So even you can generate customize app also in Earth Engine. There is an option of so you can give the drop downs of the selecting the dates and the data sets. Like here, you can generate the data set. Look, I will select okay which product you want to use, Sentinel, TOA, or surface reflectance. Then you can select the date. Okay, I want to make a composite between 1st September or let me go 1st October. Then you can even go for a select district. So these kind of customization also you can do in Earth Engine, and you can generate an app for very quick analysis. So let me just go for so you can it will show you the image or all the NDVIs and everything. You can generate the deviations. So what are the areas having problem? So this is the Nashik region. This year due to the drought, some of the areas remain fallow. So very quickly you can assess. Otherwise, these kind of analysis we're doing these kind of analysis. You need to download the data. It will take too much of time. So you can see these are the areas which are having problem. This is the average NDVI of past 3 years of Sentinel. And if you overlay the current year NDVI over that, so you will clearly see, okay, these are the areas, yellow one are having less NDVI. So definitely there is a problem. Either crop is not sown or is having the health is not good. So you can even create the deviations. So very quickly you can see, okay, these are the parts having problematic. So these kind of analysis is doing very easy these days. Otherwise, downloading data and all will take too much of time. This is the soil moisture derived from those root zone from 8 years average. And this is the some of the stubble burning also analysis, these kind of analysis you can do. Like this is the recent image. You can see some of the black scars in the Amritsar where the crop has been harvested. So some of the burnt area also you can indices you can compute in Earth Engine, like maybe or burnt normalized burnt ratio.